Moving into our last chapter, we're going to begin to switch our focus from proportions to means. So in chapter 7 and 8, our entire goal was to infer about the population proportion based off of the sample proportion. And that was because our data tended to be categorical. When you have categorical data, you're going to use proportions. For example, one question, one scenario we looked at was, do you believe global warming is a threat to your country? The answer is either yes or no. That would be categorical data you're collecting. What side will the coin land on when you spin it on the table? Would it be heads or tails? Do teenagers prefer bottled water or tap water? Those results, once again, would be categorical. In chapter 9, while we're focusing on the population mean, our data will be numeric. We're still going to use statistical inference. We're going to use confidence intervals and we're going to use hypothesis tests, but we're going to use the sample mean to make an assertion about the population mean, and we'll be collecting numeric data so we can actually get a mean. Recall that numeric data has two properties. Property number 1, the data consists of numbers, and property number 2, the mean makes sense. It has a meaning. So if we ask the question, what is your current GPA, you would give a number. It's a 3.1, it's a 4.0, it's a 2.2, and the average GPA would have a meaning. It would make sense. How tall are you in inches would be numeric data. What is your commute time in minutes would also be numeric data. So we would begin to use the sample mean to make an assertion about the population mean. Now this is going to change our notation. Back in chapter 7 and 8, we were using the sample proportion p hat to make an assertion about the population proportion p, to infer about that. In chapter 9, we're going to use the sample mean x bar to infer about the population mean mu. X bar is the sample mean, mu is the population mean. Going to use x bar to infer about mu. Also recall from some previous videos that S is the sample standard deviation and sigma is the population standard deviation. Whether or not we have sigma will make a difference with what distribution we use later on at the end of this chapter. So keep that in mind. S is the sample standard deviation. It's a statistic. Sigma is the population standard deviation. It is a parameter.